Good day, everyone. We are going to present predicates and quantifiers.
Predicates. A predicate is a sentence that contains a finite number of variables and becomes a statement when specific values are substituted for the variables. The domain of a predicate variable is the set of all values that may be substituted in place of the variable.
Consider this mathematical sentence: x is less than 3. X is a variable, the subject of the sentence, while is less than 3 is the predicate. We can write p of x equals as x is less than 3, where the value of p of x is the value of propositional function p at x. Assigning a value to x makes p a proposition if then has a truth value. The domain of discourse, or the universe of discourse, is the collection from which variables can take values. For example, if my predicate function is x is sharp, the function has a different meaning if my universe of discourse is a college student versus all tools. So it's either the college students are sharp or the tools are sharp.
Quantifiers. Quantifiers are phrases that refers to given quantities, such as for some, or for all, or for every, indicating how many objects have a certain property. Two kinds of quantifiers.
The first one is a universal quantifier. It represents an upside down A, as for all, for every, for each, or for any. The second one is an existential quantifier. It represents an E that is flipped to the right, as for some, there exists, there is a, or for at least one.
The universal quantification of p of x is the proposition p of x is true for all values of x in the universe of discourse. Is read as for all xp is x, or for every xp is x.
Example number 1. Let p of x be the statement x plus 1 greater than x. What is the truth value of this quantification? Where the universe of discourse consists of all real numbers. Solution. Since p of x is true for all real numbers x, the quantification for all x, p of x is true. Example number 2. Let q of x be a statement x is less than 2. What is the truth value of this quantification? Where the universe of discourse consists of all real numbers. Where the universe of discourse consists of all real numbers. Solution. Since x is greater than 3, it is true. For instance, when x equals to 4, the existential quantification of p of x, which is true. These are the examples of quantifiers and negating quantifiers. For this statement, for all x, p of x. When true, p of x is true for every x. And when false, there is an x for which p of x is false. For this statement, there is an x, p of x. When true, there is an x for which p of x is true. And when false, p of x is false for every x. In negating quantifiers, as you can see, there are an equivalent statement, where the universal and the existential quantifiers are before the negation. The first statement is when true, for every x, p of x is false. And when false, there is an x for which p of x is true. While the second statement is there is an x for which p of x is false. And when false, p of x is true for every x.
Every person is nice can be replaced as for anything. If it is a person, then it is nice. So, if p of x is person, and q of x be x is nice, statement can be symbolized as variation. All persons are nice, or each person is nice.
It's possible.
Translating logical expression to English form. Example. Express the statement Some student in this class has visited Mexico, and every student in this class has visited either Canada or Mexico, using predicate and quantifiers.
Rewriting the first statement, for some student X in this class, X has visited Mexico. So as you can see, we are using the existential quantifiers and framed the two predicates, which is S of X and M of X. And rewriting the second statement, for every student X in this class, X has visited either Canada or Mexico. So we are using universal quantifiers and framed an S of X, C of X, and M of X, where C of X is Canada and M of X is Mexico. So thank you, and that is all for predicates and quantifiers.